Hi everybody, welcome back to the Feynman technique. This is my fourth video in a series where I'm using kind of a similar technique to solve some integrals. The last three videos in the series, which I will link to in the description, use this same technique that I'm about to use. So the integrals we're going to be evaluating today are these two integrals. The integral from 0 to infinity of natural log x over x to the fourth plus 1 dx, and also the one where the integrand is the same except with an x squared also in the numerator. All right. So in our previous videos, what we usually like to do is start with some known value, start with some integral that we know, and then try to use some manipulations to transform it kind of into these integrals. I can't think off the top of my head. It's not really easy to think of an integral like these that we would just right off the bat know the value of. So we're going to pick this integral, the integral from 0 to infinity of natural log x over x squared plus 1 dx. And we can use kind of a trick to find that that's equal to 0. So what we do is we split that integral at the point x is equal to 1. We split it into two separate integrals. So we have that integral is equal to the sum of those two integrals. That just uses the property that the integral from a to b or from a to c is equal to the integral from a to b plus the integral from b to c. All right. Now we perform the following substitution on the second integral right here. Applying the substitution gives us this. All I did is I literally just plugged in u is equal, or x is equal to 1 over u, which is equivalent to this, into this integral right here to get this. And then, of course, I replace dx with its corresponding representation in the u world. All right, so we get that, and then you'll notice that natural log 1 over u is just negative natural log u, so we can use that negative sign to cancel this negative sign. We can distribute this u squared into the denominator here to just give us back our u squared plus 1, and then switch the bounds of integration to make it 0 to 1 by flipping this to a negative. And so what we end up with is this, and that equals 0. So we have our starting quote unquote known integral, and that is the integral from 0 to infinity of natural log x over x squared plus 1 dx is equal to 0. All right. So now let's consider this integral, the integral from 0 to infinity of natural log x over x squared plus a squared. We can factor out a 1 over a squared outside the integral and transform the integrand like this. No problem there. And then we make the substitution. W is equal to x over a, which means x is aw and dx is a dw. Performing that substitution, and we get this. We get the integral from 0 to infinity of natural log x over x squared plus a squared dx is this integral right here. All right, and we can split that integral on the right up into two separate integrals using the properties of logarithms. This is just natural log a plus natural log w. So we get these two integrals. All right. And this is what we end up with, because you'll notice that this integral right here is well known. It evaluates to pi over 2. And this was the integral that we determined evaluated to 0. So this whole integral right here vanishes. So we have the integral from 0 to infinity of natural log x over x squared plus a squared is just pi natural log a over 2a. All right, now let's let a equal I to the 1/2, or square root of I if you like. The principal value of that would be e to the I pi over 4. So we're going to sub e to the I pi over 4 in for a in this equation. So all instances of a will now just be e to the I pi over 4. All right, so we get the integral from 0 to infinity of natural log x over x squared plus I dx is equal to this. You see, I just plugged in e to the I pi over 4 into our values for a, and of course, square root of I squared is just I. All right, so now let's manipulate this a little bit. This we can use the properties of e and natural log, which are inverse functions, to just make natural log of e to the I pi over 4. That's just I pi over 4. So when we multiply it by pi over 2, we get I pi squared over 8. And then we use Euler's formula on e to the negative I pi over 4, which turns into cosine pi over 4 minus I sine pi over 4. Both cosine and sine of pi over 4 are square root of 2 over 2. So we distribute this inside, and this is what we end up with. This whole expression right here is just I times the square root of 2 pi squared over 16 plus square root of 2 pi squared over 16. All right, and we are pretty much done. So don't forget that this whole thing was equal to this integral right here. And we can rewrite this integral like this simply by multiplying the top and the bottom by x squared minus I. So now we have this, and we're pretty much done. All we have to do is match the real and imaginary parts of this, and we have the solution to our two integrals at the beginning. So the integral from 0 to infinity of natural log x over x to the 4th plus 1 dx is negative square root of 2 times pi squared over 16. And the other integral that we were trying to evaluate is just the positive version of that. All right, guys, hope you enjoyed that, and we'll see you next time.